All right, so this is going to be a video about the sum and difference of two cubes. And rather than just kind of telling you what this is all about, I'm actually going to show you the importance of it using an example. And if you haven't seen the videos from the previous section, you're going to want to watch that, so this video makes a little bit more sense. So we're looking at this one right here. It says x cubed minus 1 equals 0. Well, I graphed out x cubed minus 1 right here, and you can see that it equals 0 at 1. And you can kind of see that if you plugged in 1 right here, 1 to the third minus 1 is equal to 0. Now say I wanted to solve this algebraically, I can add the 1 to both sides and you end up with x cubed is equal to 1. Okay, and then we're going to raise both sides to the 1/3 power. Okay, well the 3 and the 1/3 are going to cancel, so you're going to be left with x is equal to 1 to the 1/3 power, which is equal to 1. But a light bulb should be going off in your head because this does not follow the fundamental theorem of algebra. The fundamental theorem of algebra states that there should be 3 solutions. Okay, there should be 3 solutions, and we only have 1. So where are those other 2? Well, the only way to really figure out where those 2 are is by factoring this. And to factor this and figure out the other 2 answers, you have to factor this using the sum or difference of 2 cubes factoring. All right, so we're going to need the sum or difference of 2 cubes to figure out those 2 other solutions. So before I try to find those other 2 solutions, let's go over the sum or difference of 2 cubes first. Okay, so we have this expression right here, this a minus b times this a squared plus ab plus b squared. Now I'm going to solve this out using the area model, which I have pre-written right here, just to kind of show you a very interesting thing that happens when I multiply this a minus b and this a squared plus ab plus b squared. All right, so the first thing I'm going to do here is multiply my a and my a squared here, and you get a cubed. Okay, this right here where they meet, it's the negative b and the a squared, so it's going to be negative a squared times b. Here it's going to be a squared times b where they meet. Here it's going to be negative a b squared. In this next box right here we have a b squared, and the last one we're going to have negative b cubed. Now the interesting thing that happens here, if you haven't seen it already, is that this cancels out with this because it's a minus and a plus. This one's also a minus and a plus, so those cancel. And you are left with a cubed minus b cubed being equal to that original expression that I had, that a minus b times the quantity a squared plus ab plus b squared. So, long story short, what you can do, if you had 2 things that were perfect cubes, so in this case it was a and b are perfect cubes, they factor to this expression right here. Okay, and the mnemonic device used for factoring this out is called SOAP. Okay, the S stands for same. So what the same means is this power, or what the same means is this right here is negative, this is also negative, so that's the same. The O stands for opposite, which just means the next operation that you're dealing with, this plus, is going to be opposite of whatever's right here. So that's negative, this has to be positive. And then the AP stands for always, and the AP stands for always positive. Okay, if you notice this one right here, it's going to always be positive. It's always going to be a plus. So you can use SOAP to try to remember the operation. So it's going to remember this one, and this one. The one thing you do have to remember, though, is the a and the b, the a squared, the a times b, and then the b squared. Okay, so you do have to remember the rest of this, but the SOAP will actually help you figure out the operations as you're going through that factored form. So what we're going to do is we're going to use this highlighted blue expression essentially to figure out the other 2 solutions that we have for that equation that we were looking at before. So what I'm going to do is copy this and I'm going to paste it over here. Okay, for our given example, it's x cubed minus 1. Technically I can rewrite that where in this case a is equal to x and b is equal to 1 because b cubed is 1, 1 cubed is 1. Okay, so essentially what we can do is use this highlighted blue part to figure out the factored form of it. So it's going to be x minus 1 because it's a and b, a minus b, x minus 1. And then it's a squared, which is x squared, plus a is x times b is 1, which you really don't need the times 1 there, so I'm going to get rid of that, plus b squared, which is 1 squared, to get a 1. Okay, so now this is essentially equal to x cubed minus 1, which we are trying to solve this for 0 here. So now what we can do is we can set each of these factors equal to 0 and solve. So this first one, x minus 1 is equal to 0. We actually already solved that one. We know that one's x equal 1. But this other one, what I'm highlighting right here in blue, this is going to need quadratic formula in order to solve. Okay, so we're setting this one equal to 0. If you notice, this is the exact same expression that I used in the previous video when I went over quadratic equations. So we should already know the solution for this because it's already been worked out, but I'm going to do it really quick using quadratic formula. So we got negative b plus or minus the square root of b squared minus 4ac, so 4 times 1 times 1. And then we're dividing this by 2a, which is 2. So you end up with negative 1 plus or minus the square root of 3i, because it's really the square root of negative 3, because this part right here that I just highlighted is negative, and then we're dividing it by 2. So now the total number of solutions, if we look at this, we have this x equals 1, that's one solution, and then we have this thing right here which has a plus or minus, so technically that's actually 2 solutions. So now, based on that problem that we have, we found all 3 of the solutions. The graph only showed the real solution here at 1. The other 2, which are just kind of lost in the ether, are actually complex numbers right here, and you have 2 plus the 1 here for 3 solutions, and that 3 solutions does check out for the fundamental theorem of algebra. All right, I'm going to do another problem really quick because that's the difference of 2 cubes. Now I'm going to do another one where it's the sum of 2 cubes. So what if I was trying to solve the following problem? X cubed plus 1 is equal to 0. We could solve this algebraically if we want. Again, we can subtract 1 on both sides, and you get x cubed is equal to negative 1. You raise both to the 1/3 power, or you can do the cube root. It is the same thing. This cancels, and you're left with x is equal to negative 1 to the 1/3 power is just negative 1. So that's one of the solutions, but again, we should have 3 solutions based on the fundamental theorem of algebra. There needs to be some way of figuring this one out. So what we're going to do for sum of 2 cubes, we're going to multiply these 2 factors out. So we have the a plus b, we have the a plus b, and then we have the a squared minus ab plus b squared. At this point, you probably know what the answer is going to be for this, but let's just do it anyway. We have a cubed, we have a squared b, we have negative a squared b, we have negative ab squared, we have ab squared, and then we have b cubed. And if you notice, again, this cancels with this cancels with this cancels with this, and you're left with a cubed plus b cubed. So essentially, this part right here is equal to this right here. And if you notice, it actually follows the same pattern as the SOAP. It's got the same operation, and then it's opposite here, and then it's always positive. So same, opposite, always positive. Okay, so we're going to actually use this fact, the fact that the sum of 2 cubes factors to this right here to solve this last problem here, and find all 3 solutions. So if you notice, we only have 1 solution here. We are trying to find the other 2. So for this particular problem, a is equal to x and b is equal to 1. So that means we can rewrite this to be x plus 1 times x squared minus x plus 1. This is technically equal to x cubed plus 1, which is also equal to 0. Now to solve this, it's going to be similar to the last one we did. You just need to set each factor equal to 0. So this factor is set equal to 0. Now I'm going to set this factor equal to 0 here. This one we already solved for as x equals negative 1. We got that right here. This one we're going to need quadratic formula for it, so it's going to be negative b, which is just going to be positive 1, plus or minus the square root of 1 minus 4ac, all divided by 2a, which is just going to be 2 times 1. And this is going to be equal to 1 plus or minus the square root of 3 times I, all divided by 2. So now if you notice, we end up having this -1 solution here and then these 2 solutions here, which means we do have the 3 full solutions, and it does work out for the answer. If you did want to check this on your calculator, you could. It would totally work. So as you can see, this is related to the fundamental theorem of algebra, which was talked about in the previous section. It still holds true with this one. Since it's x to the third, these equations are cubic, there should be 3 solutions. Sometimes the 3 solutions do not come out if you did the, if you just simply graphed it. You are going to sometimes need to actually factor it completely and use quadratic formula to find those other 2 complex solutions if needed. So that's basically sum and difference of 2 cubes. If you have any questions about anything in this video, let me know.